Today, I would like to talk with you about the voltage divider. In the previous class, we were talking about the current divider. And we said for the current divider means if I have two parallel branches, and these two parallel branches, resistors only, I don't have any voltage source or current source, then I can find the current in each branch if I know the total currents as a function of the total current and the resistors. And I think I give you example which was talking about that, and we solve more examples during the tutorial time which are dealing with that, especially for assignment number 2. Now we will talk about the voltage divider. The voltage divider is depending on two branches connected in series, and these branches have resistors. Maybe also 3 branches. I'll show you the equation that I'm going to derive right now. So imagine I have these two resistors, R1 and R2, and these two resistors are connected in series, and the voltage across R1 is V1, and the voltage across R2 is V2. And I know the total voltage. What is needed? I would like to find or calculate the voltage across each resistor as a function of the total voltage. So if you would like to compare between the current divider and the voltage divider, you can say the current divider is used for finding the current in each branch of two branches connected in parallel as a function of the total current. But the voltage divider is used for calculating the voltage across each branch of two branches connected in series, is used to calculate the voltage as a function of the total voltage. So if I would like to find V1 or V2 as a function of V total, I can say V is equal to V1 plus V2. Let us derive the equation, and then I'll let you know the equation that I'm going to use at the end for the voltage divider. So if I would like to calculate the current here in these two resistors, the current in these two resistors as a function of the voltage V is equal to what? So if I would like to find the current I as a function of R1 and R2 and the total voltage V. So I can say I is equal to what? Anyone from here? You are talking, guys. Anyone from that side can answer me. I is equal to what? You don't know? Yes, my friend. I is equal to what? Yes, you? Yes. Which V and which R? I'm asking him because he is talking. That's why I would like to pay his attention. So, like what he said, I is equal to V over R1 plus R2. So I can say that the current I is equal to V over R1 plus R2. Now, if I would like to calculate V1, V1 is equal to what? V1 is equal to I multiplied by R1. So I can say that V1 is equal to I multiplied by R1, which is equal to V times R1 over R1 plus R2. Am I right, Benjamin? I substituted in the equation only, right? If I try to repeat the same story for V2, I can say V2 is equal to I times R2, which is equal to V times R2 over R1 plus R2. So generally speaking, what I would like you to know is, if I know the total voltage V, and I would like to calculate V1 and V2 as a function of V and the two resistors connected in series, I can say V1 is equal to the total voltage V multiplied by, you are looking for calculating V1. So the total voltage multiplied by R1 divided by R1 plus R2. So I can say that V1 is equal to V times R1 over R1 plus R2. I need you to know that. By the same way, I can say V2 is equal to V times R2 over R1 plus R2. If you try to make a comparison between what I was using in case of the current divider and the voltage divider, for the voltage divider, V1 across R1 is equal to V times R1 divided by R1 plus R2. But if I would like to find I1, I can say for the current divider, I1 is equal to I times R2 divided by R1 plus R2. Are you seeing that, guys? Any question? This is the difference between the voltage divider and the current divider. The current divider is used for calculating the current in one of two branches connected in parallel as a function of the total current. And the voltage divider is used for calculating the voltage across a specific resistor for two resistors connected in series, and I know the total voltage across these two resistors. Let us see a very simple example which is talking about that story. By the way, the voltage divider can be applied to more than two resistors. It could be used for 3 resistors or 4. It is not similar to the current divider. For the current divider to use it for 3 branches, if you still remember, I simplified the 3 branches to B2, and then I found the currents, and then I repeated the same story. Do you still remember what I did for the current divider? What we did for the current divider, if I have 3 branches connected in parallel, we try to find the total resistance of 2 of the 2 parallel branches and convert these 3 branches to B2 only. And then I try to find the current in each one. Then I try to repeat the same story for the branch that's equivalent of 2 parallel resistors. If you still remember what I did for the current divider, I'm talking about that. If I have current here and I would like to find these 2 currents, I told you I will find the equivalent of those. And this guy will be converted to be something like that. Then I will try to find the current here, which is the same like this one. And we'll try to find the current in this guy, which is the same like this. Then I will repeat the same story for those. Right? But here, for the voltage divider, I don't need to do that. Why I don't need to do that? Because for the voltage divider, if I have 3 different resistors connected in parallel, I can directly distribute the voltage. Let me show you that. Imagine I have another resistor here. For example, we are talking about R4 or R3 connected in series with R1 and R2. I can say V1 is equal to I1 or I multiplied by R1. But what's I? I is equal to V over R1 plus R2 plus the third resistor. And at that time, V1 is equal to V multiplied by R1 over R1 plus R2 plus R3. And by the same way for V2. So if I have more than 2 resistors, still I can apply the voltage divider. It could be valid for 3, for 4, for whatever. Any question, guys?
So how would you do that? Would you just do R1 plus R2 plus R3?
That's it. And I will add only here R3, and I will add only here R3.
Only on a single in series, or
If all of them are connected in series. Any question? Now, let us see a problem which is talking about that story. Imagine I have, for example, these 3 resistors, and I know that this voltage is equal to 50 volt, and this resistor R1 is equal to 100 ohms, and R2 is equal to 150 ohms, and R3 is equal to 200 ohms. I would like to calculate V1, calculate V2, calculate V3. So calculate V1, V2, V3. If I would like to do that, I will say V1 equals the total voltage, which is 50, multiplied by which resistor? Yes, R1, which is 100, divided by 100 plus 150 plus 200. What about V2? 50 times over 100 plus 150 plus 200. And again, if I would like to calculate V3, this guy will be 50 multiplied by 200 divided by 100 plus 150 plus 200. And I can repeat the same story for 5, 10, 11, 12, whatever number of resistors. As you are seeing, the voltage divider is very easy and straightforward because it is depending on the very simple equation, which is V is equal to I times R. Because all of them are connected in series, I can say I is equal to V over the summation of the resistors. So it's very, very easy, and it is a straightforward one. Now, let us talk about the problem, which is similar to assignment number 1, the first problem. In assignment number 1, please stop talking, guys. Please stop talking. I'm hearing noise today. I don't know why. So I'm not forcing you to attend. If you don't like to attend, if you would like to talk, you can go. And instead of sitting wasting your time and your colleagues' time, you can leave us. There is no attendance. But please stop talking and listen. If you have a question, you can ask me. So for problem number 1 in the assignment, I asked you to sketch the power and calculate the energy delivered. What I gave you the current and the voltage. So if you would like to calculate the power, what do we need, Benjamin? Power is equal to what? V times I. So Andy, if I would like to calculate the power, I have to find the equation of V and the equation of I. So the first step for solving any problem like that is to find the equation of the current and the equation of the voltage. So what you have to do, number 1, you will divide this guy into different lines. Imagine this is line 1, this is line 2, this is line 3, line 4. And line 1, line 2, line 3, and line 4. Many of you asked me about that problem. Then I have to find the equation of each line. We studied in mathematics. If I know 2 points on any straight line, I can find the equation of that line. How? Imagine I'm talking about that line that has, for example, x1, y1, and x2, y2. For finding the equation of that line, I can say that y2 or y minus y2 over x minus x2 is equal to y2 minus y1 over x2 minus x1. And if you still remember, I told you instead of using y2, I can say y1, x1. It doesn't matter. At the end, I will have y function of x. Here, what we are talking about time and current. So instead of using y and x, I'm going to use t and I. So I can say I minus I2 or I1 divided by T minus T1 is equal to I2 minus I1 divided by T2 minus T1. This is what I have to do for finding the equation of a straight line. But I don't need to do that for that part. Why? It's constant. The slope is 0. So I can say directly V is equal to 5. I can say directly V is equal to negative 5 here. V is equal to here 5. And for this one, I is equal to 20. But you have to calculate this equation and this equation and this equation. Then after that, you will divide that into different periods. From that period to that period, find P, which is equal to VI. From that period to that period, find P, which is VI, and so on. After finding P for each period, you can draw it. Then I asked you to calculate the energy, which is equal to integral of P dt, and I will have different terms because I have different functions. So I would like to solve the similar to this problem, which is this one from the tutorial. I'm asking you similar questions. Can you please calculate the power? Can you please calculate the energy delivered to the circuit at t is equal to 4 seconds? So the first step for solving that problem is I will try to find the equation of this guy, the equation of this guy, the equation of this guy, and by the same way for the voltage. Let us copy this and go to the Word file. I did that before coming. To save your time. So I copied that guy, and now I would like to find the equation for each voltage. I will upload that, don't worry. So I will upload the solution for that on Brightspace. What I have here, let me go closer to this guy. This is what he gave me. This is the function between I and T. Let me talk about V and I, V and T, because it's very easy for V and I, because I have what we are calling constant function. So for the period from 0 to 2, what is the value of V? For the period from 2 to 3, it is 30. V is equal to 30. For 3 to 4, V is equal to approximately 10. So I'm going to do that. And again, I'm going to use the equation of this line, the equation of this line, and the equation of this line. Now, let us talk about the equation of this line. This is the function between I and T, so I need to know two different points. This point and this point. For this point, I have 0 and 0. T is equal to 0 and I is equal to 0. For this point, T is equal to 2 and I is equal to 4. So I'm going to move here and write for the current, I can say line 1 from T is equal to 0 up to 2. I will write the equation for the straight line. You told me what? You told me that this guy has 2 points, 0 and 0, and 2 and 4. So I will say I minus I1, which is 0, divided by T minus T1, which is 0, equals I2, which is 4, minus I1, which is 0, divided by T2, which is 2, minus T1, which is 0. If you try to substitute in this equation, you will have 4 over 2, which is 2, equals I over T, which means I is equal to 2T in case of you are talking about the current in the period from 0 to 2 seconds. Any question for that? Let us talk about line 2. Do we need to repeat the same story for line 2? It is constant value, which is equal to 4. That's why I will write I is equal to 4 in which period from t greater than or equal to 2 or less than 3. Some of you asked me about equal here. Should I put it in that period or in that period for 2? My answer is it doesn't matter. Because if you try to substitute here by t is equal to 2, I will be equal to 4. If I try to substitute here by t is equal to 2, I also is equal to 4. So it doesn't matter for equal. You can use equal in this period or in that period. It doesn't matter. Because I don't have this continuity. For line 3, which is this line, I have this point, which is a 3 and 4, and I have that point, which is 4 and 8. Then I can say from t equals 3 up to t equals 4, I can say the equation for that line will be I minus 4 divided by t minus 3 is equal to I2, which is 8 minus 4 divided by 4 minus 3, and this is what I did here. So you will have 8 minus 4, which is 4, divided by 4 minus 3, which is 1. At the end, I'll have 4. So I can say I minus 4 should be equal to 4 multiplied by this term, which is t minus 3. So I'll have 14 minus 12. Then I will move 4 to the other side here. At the end, I will have 40 minus 8. These are the equations for the current. I'm going to repeat the same story for the equation of the voltage for the same periods. So I'm going to say for the voltage from t greater than or equal to 0 up to 2, I can say the voltage is equal to, yes, it's not 4, it is equal to 20 here. Am I right? Why you are saying 4? It's 20. And then for the second period, from t less than or equal to 2 up to 3, what is the value of the voltage? Actually, the voltage is equal to 30, yes. And for the last period, from t greater than or equal to 3 and less than 4, I can say V is equal to 10. From 2 to 3, it is equal to 30. From 0 to 2, actually, it is equal to 20, but you didn't see it well. So it is changed right now, and it is 20. I said it 20, but actually, I wrote it 40. I'm sorry. So if you try to calculate the power, I will use the power for each period. So I'm talking about the first period. I will repeat the same story. So for part A, for the power. So for the first period, from 0 up to 2, I can say P is equal to V times I. Actually, V is equal to 20. I don't remember what is the value of I. I was equal to 4T. 4 or 2? 2T. So it is equal to 2T. So at the end, I have 40T. Then for T in between 2 and 3, I'm expecting that the power is equal to VI. Actually, V was equal to 30 and I was 4. So I'm expecting 120. And for the last one, from 3 up to 4, P is equal to V times I. So V was equal to 10 and I was equal to 40 minus 8. At that time, I will have 40 T minus 80. This is what I need. He asked me to calculate what? He asked me to calculate the power from 0 to 4. This is what he asked me. I don't need anything. In the assignment, I asked you to do the same and to draw that. Is it hard to draw that? It's very easy. You will take only 2 points to represent that t is equal to 0 and t is equal to 2. Find 2 points, this straight line. And then this guy is constant, which is 120. And this guy also is a straight line. You will substitute by using 2 points, 3 and 4, and calculate the corresponding p and connect these 2 points because it is a straight line. Any question for that? Yes.
So we had discussed that the energy delivered is the integral of
P dt.
power, P
Yes.
dt. So supposing it's a circuit with resistive elements, the direction on this example, it's always positive. In a circuit like on the assignment, the current and voltage, it's positive and negative. But would it be the absolute value of the power?
No, the power is equal to integral of p dt. It doesn't matter what is v. Integral of p dt. P is equal to vi. So it doesn't matter what is v. Positive, negative, it doesn't matter for me. So if v is function of t, which is equal to 5t plus 10, so I will plug it in my equation. I will find the integral. Imagine that v is equal to negative 40, and the current is equal to 5t plus 6. So I will multiply the negative value times the current. It will give me equation, find the integral. It doesn't matter for me what is that value. At the end, I'm finding the integral. You get what I mean?
So my question was.
I got what you are talking about. You are talking about if I have negative and positive voltage value.
Yeah.
At the end, I'm multiplying V times I.
Yes.
It doesn't matter this guy if it is equal to 5t plus 6 or negative 60 or positive 60. At the end, I'll have a specific value, which is negative 60t plus 20. Find the integral of that.
So yeah, that's like kind of the pretext to what I wanted to get to. So on the graph of power, you would have positive and negative sections. So if in that circuit you had dissipated, say, 100 positive watts and then say another 100 negative ones, would the integral of that be 0, even though 200 watts have been dissipated?
If you have positive P and negative P and they are equal, the integral is equal to 0.
Okay.
Because what I give you in that problem, I didn't give you which elements we are talking about. I give you the value of the voltage. Maybe the element that I'm talking about is a resistive element. Maybe the element that I'm talking about is capacitive element or inductive element. So it depends on the element for that period. Maybe positive, maybe negative power value. It depends. Maybe generated power, maybe absorbed power. But at the end, I'm dealing with this problem as if I have a specific component of power and I'm finding the integral of that. At the end, I have a certain value.
Okay.
But later on, while we will talking about what is left in the course, we will start talking about the capacitor and the inductor. And we will say different story for the inductor and the capacitor. How to find the power for those, this is a different story, and there will be different equations that we are going to use. Okay. So the next step is to calculate the energy. Here, I asked you to calculate the energy delivered to the circuit at t is equal to 4. So I'll try to find the integral for all components for different periods. I know that W for part B, I know that W is equal to integral of P dt. But the problem here is I have different functions for the power. So because of these different functions for the power, I am expecting that I have different terms. That's why I will divide my integral into 3 terms. The first term is integral from 0 to 2. The second term, integral from 2 to 3. And the third term is integral from 3 to 4. So this guy will be equal to integral from 0 to 2 for what? For 40t dt plus integral from 2 to 3 for 120 dt plus integral from 3 to 4 for 40t minus 80 dt. So this guy will be equal to integral for 40t will be equal to 40t squared divided by 2. Yes, so this guy will be equal to 40 t squared divided by 2. This is from 0 to 2 plus 120t from 2 to 3 plus 40t squared divided by 2 from 3 to 4 minus 80t from 3 to 4. And then you will substitute in your equation by saying this guy is equal to 20 multiplied by t squared, which is 2 squared, minus 0 squared, plus 120 times 3 minus 2, plus 20 multiplied by 4 squared, plus minus 3 squared, minus 80 multiplied by 4 minus 3. Am I right, guys? Then I will have 20 times 2 squared, so 20 times 4 will be 80, plus 120, plus 4 squared will be 16, minus 3 squared, which is 9, so 16 minus 9 will be 7 times 20, 140, minus 80 multiplied by 1. So I have here 80 plus 100, which is 120, which is 200, plus 140, it will be 340, minus 80, it is 260. G. Any question for that problem? Yes, go ahead. No, it is minus 80 because here 40t minus 80. So I wrote this guy 40t squared over 2 minus 80t. You got it? Okay. Any other question, guys?
So for the assignment, is it acceptable if we just like count up the area under the power curve?
Yes, it's fine. If you would like to find, once you calculated the power, you don't need to find the integral. If the power is a straight line, you will find the area under the curve, and that's it. Because it will be more easier for you. But if you have a curve, this problem, you have to find the equation to be able to find the integral because the area under the curve is approximated area. Right?
Yeah.
Yes.
The first question from the assignment, I ended up sketching the graph. The graph I didn't have to do it, and I was able to draw the line, or will I lose grade?
So this is the problem that we are talking about. I didn't get your question. What are you saying?
So basically, I was able to draw the sketch the power versus the graph without
By multiplying this guy by this.
Yeah.
I'm multiplying this guy by this.
Yeah.
That's fine. Why? Because we, like what I told, what's your name?
Matthew.
Matthew. Matthew is asking me, can we find the area under the curve? I told him yes, because you are talking about straight lines. So if you have this guy and you would like to multiply this guy by this value, so it will be shifted somewhere. If you are able to find the new equation from the graph and it is right, you will not lose marks. But if you didn't find the right answer for the straight line from the graph, you will lose marks because I didn't see any step. I saw you like drawing something. So probably you will lose the whole mark for that part because I'm not seeing anything except the graph. So probably you will lose the mark for that part if it is wrong. If it is right, no, you will not lose anything. Any question, guys? Let us see another problem from the notes. But actually, this problem is not related to the assignment. Before leaving, any question for the assignment? Any question for the assignment? I think we have already covered problem number 1. Problem number 2, I think it's straightforward. Any question for this problem? Yes. Okay, any question for problem number 2? Again, if you try to look to problem number 2, I believe there will be only this resistor and this resistor at the end, right? Any question for this problem? Problem number 3? Yes. Who's to? Yes. Yeah. The current is 0 because of symmetry. You know what? I will try to solve this problem with you here. Oops. Because I still have time, I can solve it with you. So many of you asked me about that problem. This is the assignment problem. So I'll go over this problem. I don't mind to help you for the assignment, but at the end, I'd like you to understand what I'm covering. This is the importance of the assignment or the tutorial. If you try to look to this problem, this point and this point and this point and this point are connected. How did I know? Because I told you this is the ground and all of them are connected to the same point. Even if I don't know that this is the ground, this is the same, like this, like this, like this. I have the same picture or the same feature for all of these. So all of these are considered as one node. So I can draw this circuit like that. This guy is 400. This guy is 120, and this is 120, and this is 0.2, and this is 0.2. What I told you, if you don't like to waste your time, and you realized that the voltage for this node is the same like the voltage for this node. How did you know? Because this resistor is the same like this. And this current source is the same like this. So I'm seeing symmetry between both sides. And in between, there is only one branch. I don't have any other circuit. So I am expecting that this voltage is equal to that voltage, which means there is no current in this branch. Based on that, I can say the current in this guy is equal to 0. Because I have the same voltage, the current in any branch is equal to this voltage minus this voltage divided by this resistance, or the voltage difference. So here, I don't have voltage difference between these 2 points. That's why I don't need to do extra calculation. If I realize that from the beginning, I will say, since this voltage is equal to that voltage, I can say the current here is equal to 0. And based on that, I will not have any current in 400, and 0.2 will go directly to 120, and 0.2 will go directly to 120, and that's it. What about if I didn't realize from the beginning that the voltage is equal? That's okay. It's not the end of the world. I will write my equations and I will reach to the same story. Let us do that right now. But before doing that, some of you are asking questions. Yes, go ahead. No. It's depending on the circuit configuration. I couldn't say yes or no. But what I said, I'm looking for a specific position or a specific value. If there is a symmetry by inspection, I can say yes. So the voltage is equal. At that time, the current is equal to 0. But here, if there is no symmetry, no need to guess. It's better to solve the problem, because at the end, it depends on the configuration of the problem. Let us see how to solve this problem, and I will repeat solving this. When I will talk about node voltage method, in 2 steps I can solve it by using a new theorem, modified theory, which is called node voltage method. But I didn't start talking about that. So I'm going to use the basics that I learned, Kirchhoff's current law and Kirchhoff's voltage law. So do we know the current in this guy? I don't know. I'm going to solve the problem as if I didn't realize that there is a symmetry and the voltage is equal. So if I realized from the beginning that there is a symmetry, I can say that if I realized this voltage is equal to this voltage, this is V equals to V, at that time, the current here is equal to 0, and the current here is equal to 0.2, and the current in this guy is equal to 0.2. But right now, I'm going to solve it using another solution. What is the other solution? The other solution is, I'm going to assume that I didn't realize that the voltage is equal. And I'm going to use KCL and KVL. Am I going to be able to continue solving the problem? The answer is yes. Let us see. I will assume that the current in this guy, is, for example, I1. So the current in this guy will be what? Summation the current here is equal to 0. So it is equal to 0.2 minus I1. Am I right? Are you seeing what I'm talking about, guys? So since you told me that the current in this guy is I1, I can say the current in this guy will be 0.2 minus I1. Excellent. If the current in this guy is 0.2, and the current in this guy is 0.2 minus I1, summation the current for this node is equal to 0. Let me write, for example, this is node number 1, and I will imagine that the current in this guy is equal to I2. So if I said summation the current is equal to 0 for node 1, I can say 0.2 minus I1 is hitting that node, minus I2, which is leaving the node, plus or minus this guy is hitting, and this guy is leaving, and this guy is hitting. So this plus this minus this. So plus 0.2 is equal to 0. Am I right? Now I will have 0.4 minus I1 equals, excellent. Can I say summation the voltage for this loop is equal to 0? Summation V equals 0 for loop 1. Now let me put my signs. Positive, negative, positive, negative, positive, negative. Am I right? I will keep the second sign, the second sign, the second sign. So I will say 120 times I1 minus 400 multiplied by 0.2 minus I1. right? Minus 120 multiplied by what? What is the value of I2? Yes, so multiplied by I2, which is 0.4 minus I1 equals 0. Okay, guys, let me calculate. So 120 minus 400 I1 minus 100 I1 will be equal to, I'm not hearing, 400 I1 minus or plus. I have here minus times minus will be positive, minus times minus will be positive, right? So the total will be 120 plus 400 plus 120. It will be 640 I1. Then I will have negative 400 times 0.2 minus 100 times 0.4. So this guy times this guy will give me, and this guy times this guy will give me, I'm not hearing, 48. This guy is equal to 0. Then based on that, I can say I1 equals 128 divided by 640. Can anyone calculate this number? Anyone calculate this? 0.2? Oh, it is 0.2. What about I2? Substitute in this equation. So 0.4 minus 0.2 again. It gave me the same current that I said from the beginning. So if you got lost and you don't know that the voltage is equal, you can follow these steps, but you will realize at the end that the current is equal to 0.2 for both sides because of symmetry. Any question for that part? So I'll stop right now and I'll see you on Monday to talk about the new lab. Have a great weekend. If you have any question, you can come to me. Just 1 second.
Yeah, no problem.
I will stop recording first. Then I'll be back with you.